Okay, we are on this exciting artificial intelligence era, especially for us developers. We have a lot of great tools in our hands to build applications. And this is what TDX is for. You have seen a lot of different technologies that can help you rely on AI for your apps. Today, I'm going to be showing you how to start building AI applications and deploying those applications on Heroku. Remember that Salesforce is a public trading company, so please don't make any financial decisions based on products that are not yet publicly available. And for all of you, thank you very much for joining us here at TDX, and also for all the people that is watching us right now on Salesforce Plus. Thank you. We are making this content for all of you. My name is Julián Duque. I am the head of developer relations at Heroku. I'm in charge of creating content and connecting with developers, educating and enabling you to be successful on our platform. And all of my social networks are always open if you have any questions after this session. What are we going to be covering today? Well, first, we need to see what is Heroku and, of course, why it is awesome. Second, let's have an overview of how to start building AI applications on our platform. Then I'm going to be showing you one of our recent projects, which is reference applications, or some open source applications that you can start using today to learn how to build AI on Heroku. Then I will be teaching you about some current AI applications patterns that you can start using today. And at the end, I'm going to be showing you a little bit of what is coming in the future regarding AI for Heroku developers. So what is Heroku and why it is awesome? Well, Heroku is the fastest way to deploy an application to production, to get an idea and get it ready, publicly available to production. Heroku takes care of all of the different DevOps tasks that you need to take care by yourself. We are doing all of that heavy lifting that DevOps teams need to do by their own. When you deploy an application to Heroku, we have an opinionated platform, so we are choosing the right operating system for your app. We are choosing the right CPU and memory that your app needs to be executed on. We are also configuring all of the necessary cloud services for your app to be publicly available, like networking. We set up firewall, routing, all of the networking configuration, DNS, and also we take care of SSL and TLS for you. Also, we have all of the security access management for your applications, and you can also have your team collaborating with you on your apps. We are deploying an application right now, and now that the application is built, we are going to make it public, so anybody can access to it. And now you can see that in less than 2 minutes, we took one of these reference applications and we deployed to the cloud, and now it is publicly available. This is pretty much why Heroku is awesome. So what is Heroku? Heroku provides managed compute and data services to deploy and run your applications. You as developers, you need to focus on building your apps. You are going to deploy those apps to Heroku. We take care of the application management, the data services, and all of the different developer tools to properly run your application, so your application can be made publicly available to your users. To explain a little bit more about this, the idea is for you and your resources, the people in your company and in your team, to focus on the business, to focus on the applications, not on how to operate those apps. Here is a comparison between your regular infrastructure as a service and Heroku. With infrastructure as a service, you will need to have a lot of people managing the infrastructure of your applications. Some other people operating those apps, and you might not need like the right resources to have people building those exact applications. Since Heroku takes care of the infrastructure and DevOps for you, you can put all of those resources, all of those people and talent on building the apps so your customers can be more successful. And speaking of apps, let's take a look at the type of applications that you can start building on Heroku. The first thing is that you are going to be using open languages on our platform. We are using open source languages to build these applications. Here in Heroku, we support multiple languages like Ruby, Java, PHP, Go, Scala, Clojure. But the ones that we are going to be covering today are two of the languages that has most of the AI market share today, which is Python and Node.js. So right now, most of the different large language model services out there and most of the prominent frameworks and libraries are built using Python and Node.js. This doesn't mean that you cannot build AI applications with Java or with Go. You are going to find also open source libraries available in these ecosystems. But mainly, most of the official support are going to be around Python and Node. And good news, we also support Python and Node.js applications on Heroku. Also, to build AI applications on Heroku, we need to choose the right tools. Personally, I like the following ones that I'm going to be showing you, but there are others available that you can use. If they support either Node, Python, or some of the languages we support, you can build with those technologies. For the apps I'm going to be showing you today, we are using OpenAI as our large language model provider. Pretty much we are relying on OpenAI for not only the GPT or the completions API to perform AI operations, but also for performing embeddings, which is transforming text or data into vectors, into numerical information. We are going to be explaining a little bit more later. But this doesn't mean you can use other services like Anthropic or the services provided by Google, or also the ones provided by Salesforce as well. We are also going to be using LangChain. What is LangChain? LangChain is a framework for developing and orchestrating applications powered by language models. LangChain has official support for Python and Node.js, and this allows you to create complex AI-enabled applications. It has a lot of different classes and patterns where you can build different types of applications, and it has a lot of great support. And the LangChain libraries are open source, so you can also contribute to them and use them without any problem on Heroku. But again, you can use other type of frameworks and libraries that are out there, like Llama Index, or you can use exactly the specific SDK that are available from the different AI providers that you are using, like the OpenAI SDK. We have an example using that one, or the Anthropic SDK, etc. And last but not least, we are going to be using pgvector. pgvector is an extension of PostgreSQL that makes PostgreSQL act as a vector database. So it allows us to store information as numerical data structures in our database so we can perform similarity search operations over the data. By using certain specific mathematical operations, we can get data that is semantically closer to what I'm looking for. And good news, at Heroku, we support pgvector. We recently announced support for pgvector on our Heroku Postgres database. Now let's take a look at reference applications. Personally, for me, one of the best ways to learn is by looking at code, by looking at applications that already exist, and also by doing. If I just look at the application, but I am not building anything, the learning process might be a little bit difficult for me. So I like to get these applications change them to suit my needs, so I can see then and get inspired what can I be building beyond that. So what are the reference applications? We recently launched this open source repository, and don't worry, don't take pictures. I'm going to be sharing all of the resources at the end. We recently released this open source repository with multiple applications. As of today, we have 3 different reference applications that uses AI and Heroku technologies. We are not stopping here. We are also going to be publishing other type of reference applications, like how to use Heroku with Data Cloud, how to call like prompt templates from a Heroku application, or even copilots, as we announced yesterday at the developer keynote. So let me show you the 3 applications that we have today that you can start like deploying to Heroku and looking at the source code. And also, if you want to contribute, these are open source projects, so please be my guest. The first application, it's called Menu Maker. It's a cute example where we can pass a list of ingredients to a web application, and it's using OpenAI or ChatGPT to come up with a recipe. So if I have 3 or 4 ingredients on my fridge and I want to prepare dinner tonight, I need inspiration, I can add those ingredients and then get the result. But hey, Julián, I can do this with ChatGPT directly. Why are you building this full application for that specific use case? Well, what we are showcasing here is the future of function calling. LLMs, sure, they can give you a lot of information, but normally they cannot perform actions. In order to an LLM to perform actions, now we need to build something called an agent. It's an LLM application that can perform actions automatically or autonomously. OpenAI supports this feature, which is function calling. Basically, we are telling OpenAI, hey, I need you to do this specific task, and the result, I need the result with this specific structure, as a JSON structure that has these specific properties with these specific types, so I can use that data structure as the input of a function of my application. So automatically, the LLM is bringing that structured data and executing a function on my code. For this app, we are using Node.js. We are using Express as our API. This is a React application, so you can also learn how to deploy React applications to Heroku. We are using the OpenAI SDK directly with the library that is supported officially by OpenAI. We are using the ChatGPT functions feature. And the language model we are using is GPT 3.5, the latest version, which is faster and more accurate. Let me show you real demo. Let's hope internet works and we don't have any issues here. I'm going to be giving a list of ingredients. Who can help me with ingredients? You. 1 ingredient. Pepperoni. Pepperoni. Awesome. Pepperoni. I hope that's correct. Cheddar cheese. And tomato. Let me see. What can I make with these 3 things? Okay, I can do like a cheddar stuffed pepperoni tomatoes. That sounds good. It is giving me the title of the recipe. It is giving me a description and the list of ingredients, the quantity, and the steps, like the recipe. So if you see, those different things are on different parts of my UI. This is why I need the structured data. So what this application is doing? Okay, me and my browser application, I am sending those ingredients to the API I am internally exposing. Then I am creating a prompt, and I am specifying that prompt with the specific data structure that I need to execute the function on my UI. I need a title, which is a string. I need a description, which is a string. I need a list of ingredients, which is an array of strings. and I need a list of steps, which is a list of strings. I send that to OpenAI. OpenAI comes up with the recipe and returns that JSON formatted data, so I can parse it on my application and showing that on my UI. Since I am going to be sharing this source code with you, I will invite you to go later and take a look at the source code and check how all of this operation is being done. And we also publish a blog post how to build this whole application that you can take a look at the Heroku blog, and I'm going to be sharing that link also later. Now let's go to the next reference application. Recently, OpenAI released these Copilot type applications called GPTs. Anyone has created a GPT here from ChatGPT? Yes, 1, 2 people. Basically, you go to create a new application, and you are building this application using natural language. So you are going to perform this specific task. You can add certain specific abilities to this GPT. For example, you can generate images, you can browse the internet, but there is one specific feature of a GPT, which is you can execute actions. So this is another type of agent. So we are giving kind of like superpowers to this AI application so it can execute actions on your behalf. So a GPT action is basically an API that exposes all of its structure using the Open API specification. Do anybody here has worked with the Open API specification? The Open API spec? If you have not, that is going to be our next reference application, how to write APIs using the Open API specification. And that's one way you can also have external APIs integrated with Salesforce through external services. It is a standard that can pretty much describe how an API can be executed. And what we did was creating this GPT application on ChatGPT, and we told it, okay, you can also perform actions by calling my API. My API is an employee directory. It receives a query using natural language, and automatically it's performing another agent operation, which is transforming that natural language query that I am performing into an SQL query so I can get data from my Postgres database and then returning that information back to the person that is executing this application. So if you have people that is not technical, they don't know anything about SQL, but they need to create reports, fetch information, they can just ask by typing words. And then the agent is taking care of all of the technical parts for you. We are also using Node.js for this example, and specifically the OpenAPI specification and GPT actions. I have an example here. Let me see if it works. This is my ChatGPT. This is the application I created, employee directory. And if internet is working, let me ask a question. Who was the most recent hire in the marketing department? And what is their email? And even if I have a typo or something like that, it will understand me. Now it will try to call the API. I will confirm. It is calling Heroku right now, and on Heroku is performing that operation, and it is fetching the data, and now the data is also being shown as natural language. The most recent hire in the marketing department is Zachary Welch, who was hired as a manager on September 8th, but they don't have their email. Okay, that's good, but we have the information from the database. How this works? From ChatGPT, I'm asking that question to OpenAI. I'm still on OpenAI. OpenAI then sends that action to my API, which is on Express. Then I am performing a conversation between my application and OpenAI to transform that natural language query into an SQL query. I have a prompt. When I am telling OpenAI, this is my specific data schema, so you know how to create those SQL queries. And then I am executing that query over my Heroku Postgres database, and I'm going to perform the response to the user to transform that structured data into natural language data. And last but not least, and we are showcasing this application on our vector database Heroku Postgres demo booth at the platform park, where we have the Heroku booths. This is using a technique called retrieval-augmented generation. Retrieval-augmented generation is where you are using context that you have at hand to augment a prompt. Normally, large language model applications, they hallucinate if they don't have the right data. This is why having the right data is so important for these large language models. With retrieval-augmented generation, what I'm doing is providing my data to the large language model so it can get the answer exactly from that specific prompt. And to get that specific context or that specific data, I can use different techniques. This is the retrieval part. And here, for the retrieval part, we are also using pgvector, our vector database, to perform a similarity search. So any question that I'm doing, it's going to try to get all of the documents that have like some semantic similarity and term similarity of what I'm searching, getting those documents, sending those documents to the large language model so it can find the answer exactly in the prompt. So it doesn't guess or it doesn't hallucinate or come up with its own answer. So we are grounding the answer. For this, it's a little bit more complex application. We are using LangChain to perform all of the retrieval-augmented generation operations. And we are using pgvector. We are storing our PDFs on Amazon Web Services 3. And we are using two different language models. One, GPT 3.5 for do the auto-completion, and the embedding ADA model to transform text into embeddings. Remember I told you embeddings is just a numerical, multidimensional vector representation of text data that then I'm going to be comparing using a similarity search, which is performing a mathematical operation in the database. Let me show you an example of that. So we have this application here. I can upload a PDF, but I already have some PDFs upload. Let me open the cookbook. So it's a PDF with more recipes. I'm trying to eat healthy, so let's see. Give me a recipe with flank steak and yogurt. And you can prepare Greek style flank steak with tangy yogurt sauce. And I'm pretty sure somewhere in my PDF I have that specific recipe. I'm not sure if I can quickly search here, but it's somewhere on my document. Or I'm also a huge Dungeons and Dragons fan. I've been playing since I'm 7 years old. So here I have the basic rules of Dungeons and Dragons, and I can ask questions about Dungeons and Dragons. Tell me the subclasses of Rogue, and let's see. The subclasses of Rogue are Thief, Assassin, Arcane Trickster, Mastermind, Scout, Swashbuckler, Inquisitive, and Phantom. And it's getting that from the PDF document. Thank you very much. So let me isolate that specific pgvector operation. So when I'm asking the question here, I am just doing the retrieval part, not the LLM part. When I'm asking the question, what can I cook with flank steak? It is retrieving the documents from pgvector, the pieces of text that I store. And the distance. The distance is pretty much the similarity between the question that I'm asking and the result. It's a type of scoring that I have, so I know what are the most accurate answers. And we can see we have the Greek-style flank steak with tangy yogurt sauce. This is the recipe that it returned. It's the first response. We can see the term embeddings. That question was transformed to that numerical structure. And it is using that numerical structure to perform the vector operation to get the responses. And we are also storing the PDF metadata. So all the metadata from the PDFs, we are storing it on our database, because on my application, when I am asking a question, I am asking a question just to the PDF that is open. So this is why I can search and filter just my specific PDF by using its metadata. And also it is showing me that that specific answer, it's on the page 20. So if I go to my PDF to the page 20, I can exactly see that recipe. So I can build my application to return the metadata and have like a more useful result. So now the architecture for this one, we have two different operations here. One is the document that I'm uploading and transforming that document into vectors. And the other one is the question that I'm asking to the document. So I will upload the PDF, then I will perform some operations. I will store the PDF on Amazon. I will store the metadata, which is normal data, directly on the database. And then I need to get all the text from this document and split it into different chunks of text. Normally, large language models have something called the context. The context is the size of the prompt that I can send and the size of the response it can have. So you have here like recent news that there are like models that support like 1 gigabyte of context, that are like bigger models. There are other models that have more smaller context. So this is why we are trying to limit the amount of information we are sending to the large language model so we can get like a more accurate response instead of sending the whole document in one single query. So we are splitting the document, then we are getting the embeddings, which is transforming that text into vector information by using OpenAI, the embeddings API for this. And then we are storing those embeddings into our pgvector database. So this is the first step. I'm loading information. Second, as a user, I'm going to be asking a question. So if you see down, I'm asking a question. I need to transform that question into vectors to perform that mathematical operation. So I will use the same embeddings API. Then I will use pgvector to perform a similarity search. I'm using an algorithm, a special query, an SQL query to compare these terms and the terms that are stored. And then I am getting those responses to build a specific prompt. So I have a prompt template that I can pass the context of the result. I send that prompt to ChatGPT. I get the answer, and I reply my user. And that's the whole architecture of the application. And if you want to learn more, visit us at the booth, and you can get all of the directly explanation in there. Now let's talk about the AI applications patterns we saw in definitions and a more stripped down version of the demo with code. We are developers, we want to see code. So one of the patterns we saw at the beginning were agents. Basically, I mentioned that an agent is an AI application that can perform actions. These actions, imagine like they are using tools. You are providing tools to the large language model so it can perform actions for you. And these actions are being done in behalf of the user, or they can be done automatically as well, autonomously as well. So the user submits a query to the agent, which is the application that I built. Then that agent interprets the instructions, and then it will leverage the model to execute those instructions. It will select the type of tool that it will execute depending on the instruction. It will process the output and then deliver the response. And let me give you an example of the agent. I will be sharing also this demo with you. I have two agents here. One, it's using LangChain. I'm using the LangChain framework to build this agent. So basically, this agent can get the information about the weather by city. If you go to ChatGPT or if you go to any large language model, and if you ask about the query, about the weather, the large language model doesn't know because it is trained by information that has like a certain specific cutoff. So it will guess, but it will not give you the exact answer. You will need to provide a tool to the large language model so it can know the exact information that you are asking. For example, the weather. So right now, what is the weather in San Francisco? Let me see. The weather in San Francisco is 52 with broken clouds. This is why we are wearing jackets. It's gray outside. Hopefully it doesn't rain today. So how this works? So I'm using OpenAI. I'm using the GPT 3.5 turbo model. And then I am creating a tool for my application to execute. So this tool is called getWeather. And basically what it does is execute an API call. I'm calling the OpenWeather Map API, passing the city, and getting the exact weather from the question that I am asking. Then I create a prompt template. You are an assistant who knows about the weather. As a human, I am going to be giving you an input, and then I'm going to create a chain. This is why it's called LangChain. A chain is pretty much where I am chaining together different tools and different AI actions to perform one specific operation, which is going to be get the weather. And now here I am putting everything together, and I can execute it with the question that I am passing from the interface, and now it knows how to get the weather. This is the code example. You can copy and paste it and execute it. You will need to have like an OpenAI API key, and that's it to execute the example. Oh, and also a API key for the OpenWeather service. But the tool can be anything that you can imagine. So it is custom code that you are building and giving that power to your AI application. The other agent is an assistant. Here I am using directly the OpenAI SDK. The OpenAI SDK also supports a way to have agents. One of those agents are assistants, so I am also giving this assistant certain capability, and the capability is execute code. So you have the option to execute code, or the future is called code interpreter. So basically I am telling OpenAI, perform this certain operation and rely on code that you will create. Usually it generates Python code, it will execute the Python code, and it will give you the response. So here I am creating the assistant. This assistant is useful to convert units of measurement. Remember the recipes, it's giving me the things in ounces. I'm Colombian, I don't know ounces, I know grams, I know other types of measurements. So I need an assistant to do that. I don't want to use my calculator. Then I create the assistant. I create the conversation between the assistant and myself. I am also adding some additional instructions to the assistant. And I am executing the code. I am waiting until it's completed, and then I pass the response back to the user. So how much is 20 ounces in grams? It's approximately 567 grams. Okay, so it is doing the code execution for me, it is performing that operation, and that's it. Thank you very much. And last but not least, let me show you the retrieval-augmented generation as an isolated operation. As I mentioned before, it retrieves relevant information from a database, and it will respond to a query to augment the context of that query to get a proper response. So I'm querying the retrieval system, in this case, the one that gets the information from the database. I am retrieving the documents. I am creating that big prompt with the context. I am sending that information to the generative AI model, and then I am getting the exact response. Let me see the example. So now in this example, what I'm doing, instead of a PDF, I want to ask questions to a video. I'm using YouTube, I'm getting the transcripts or the subtitles of the video, and I will store that information in my database, and I can ask questions to that video. So I have a video here that I will load. So when I load the video, it's retrieving the transcripts. You can search it on YouTube. I am also doing like a 1-hour workshop how to build AI applications on Heroku. It loads the information, and now I can ask questions. What database can I use to build AI apps? And it will give me the response, hopefully from the video. You can use a vector database to build AI apps. Yes, but what vector database? I need to tell me pgvector, okay. I mentioned in the video pgvector, I asked the question, now it gets the answer from the video. So I'm using a class to load that information, which is called YouTube Loader. I'm using embeddings also to transform that text into vectors. I am connecting to the pgvector database that it is hosted on Heroku. I initialize that vector store. I create a retriever. This is the one that is getting the documents. I load the video information. I split the video, similar operation. I get all of the different characters. I store that into my database. Now I can start asking questions. So I create a prompt template. You will answer questions only based on the following context, which is part of a YouTube video. You will use a friendly language. If you don't know the answer, don't try to guess. Simply say, I don't know. If I ask something that is not on the video, it will not reply about it. I am passing the context. I am passing the question. I create the chain, so basically using that prompt and connecting everything together. I have the question and answering chain, which is the one that is putting everything together to send the mixed documents to the AI, and I'm getting the response. So now, since I am using LangChain, I can use a tool like Langsmith to debug that specific operation. So here we have the last question, which is the retrieval QI chain. I can click on it. This is the question that I ask. I can see the operation that retrieved the documents, vector store retriever. I see the part of the video that it fetched to create the context, which is part of this specific YouTube video. JEE, yes, it's the video I uploaded. It gets different pieces of context. It creates the prompt here. Let me see. This is the prompt. You will answer questions. This is the context. And the answer is you can use a vector database. If we see the executor, hitting the executor is a little bit more complex. It is also executing the getWeather. This is the response from the getWeather and the other different operations that we are doing to create this specific example. Now, since we are running out of time, quickly, what is the future of AI on Heroku? Where are we going? We ask ourselves the question, who are the Heroku of AI? We are always being recognized as having one of the greatest developer experience out there. So the answer was, we are the Heroku of AI. And we want to offer the same user and developer experience to our developers. So we are working on having this. You will create your Heroku application. You will be able to add an open source model to your application, and then directly from your app, perform inference questions to that model. So now you are not relying on a large language model that lives outside the trusted boundary of your application. You are going to be asking those questions directly to the large language model that lives within your app. This is where we are going. You will be able to rely on multiple different large language models, open source language models, or your own, and get the best of the Heroku developer experience in your applications. Now, get the cameras, scan the QR code. You are going to open this application with the examples and a lot of different links with the source code, blog posts, videos, all of the different learning resources. If you want to see the demo, just click on the logo on top and you will go to the first page. And thank you very much. Don't miss the rest of Heroku at TDX. Later today, we are going to have a great session. Choose the right AI model for your Heroku application. We have some hands-on activations. The AI Arcade, if you want to win some prizes, go ahead and challenge yourself, solve code challenges with an AI assistant, and also learn how I build that game for you. We have a mini hack on the Camps mini hack, how to integrate a Salesforce application with Heroku using an open API specification, and the two demos, Heroku Connect and Vector database with pgvector on Heroku Postgres. Please, feedback, share your feedback. It seems they are going to give you a $5 Starbucks gift card. And I guess the time is out for questions, but you can get me outside and ask me all of those. I will be available for you, or visit me at the Heroku booth. Thank you very much.